For this question, we might have a strong temptation to want to rationalize the denominator. But instead of doing that, let us recall that for any two complex numbers, the laws of modulus apply like this. Whereas argument works something like this. So for this particular question, you can write this down. And now let us draw the Argand diagram. I minus 1 is negative 1 plus 1i. Well, root 3 plus I will be in the first quadrant. So for negative 1 plus I, it has modulus square root 2 by Pythagoras theorem. And arguments we can work out to be 3 pi over 4. Now, we can do the same for root 3 plus I and find its modulus to be 2 and its argument to be pi over 6. So after simplifying, we obtain square root 2 over 4 for the modulus and 5 pi over 12 for the argument shown. In order to find the fourth roots of z, we solve the equation w to the power 4 equal to z, which is r e I theta. As usual, we add multiples of 2 pi to the argument. And then try to rewrite the power with a common denominator. So that when we take the fourth root, we divide each of the powers by 4. Now we sub in our 4 consecutive values of k, 0, plus minus 1, and let's include negative 2 as well. Because we chose wisely values of k around 0, we find that this time round, all our arguments are within the principal range. Part B looks weird. Notice that I wrote down the conditions on A and B. Often we overlook that and stop with the equation. But it's important to take note of the conditions on any unknowns. As this looks like exponential form, let us go back and write z in the r e I theta form once again. And I'm going to cube both sides of the equation. Which means that I'll multiply the power by 3, so I get 5 pi over 4. Whereas the coefficient becomes 2 root 2 over 64. Which reduces to root 2 over 32. In order to rewrite this number as e to the power something, we need to be able to rewrite root 2 over 32. How do we do that? If you have a solid understanding of logarithm and exponential, we will recall that e to the power ln a is equal to a for any a. So can we do it here? This a here becomes e to the power ln root 2 over 32. And now, by our laws of indices, we can add up the two powers. But hold it. A is a real number. That is true. But B is not between negative pi to pi. Oops. So we have to reduce it by 2 pi to get negative 3 pi over 4. Therefore, a equal to ln square root 2, oops, I wrote it wrongly, over 32. And b is equal to negative 3 pi over 4.